Okay, make sure your calculators are out. We pick up a little bit right where we were yesterday. And look at a different example. It says the distance an object has fallen from a still position in meters after t seconds is modeled by the equation s of t is 4.9 t squared. So here's what happens. I have an object. I'm going to drop it, okay? And somebody guess about how much time did this spend in the air. Ready? Ready? Who's going to do it? Who's going to do it? Who's my man? Okay, thank you, Tyler. Tell me how long it spends in the air. Ready? Go. All right, 1.2 seconds. Great. Okay. So if I drop it from, say, 6 feet, 7 feet, spends 1.2 seconds in the air. That's what this tells us, okay? The amount of time in the air, 1.2 seconds, that will tell us the number of feet that it's fallen, all right? It says find the average velocity, time elapsed, for the time period beginning when t is equal to 3 and lasting a certain number of seconds. Lasting, say, 1 second, okay? Lasting 0.5 seconds, lasting 0.1 seconds, and lasting 0.01 seconds, okay? So let's understand what this is asking, okay? Average velocity. Average requires 2 points, at least, correct? So yesterday when we were doing this, the secant line gave us average. What we're concerned about in calculus is instantaneous. And that would be the slope of the tangent line. Okay? All right? Now, let's just do some work right here. Got your calculators ready to go? Here we go. It says find the average velocity for the time period beginning when t is equal to 3. So, at time 3, let's see how far the object's fallen. Use your calculator to tell me at 3 seconds, how far is the object fallen? It's been falling for 3 seconds. How far has it dropped? What do you got? Ooh, it's going to be a long class. 44 point what? 44.1. Excellent. So this is really our point P. Okay. Now, if it's at time equals 3 and lasting 1 second, so it's fallen for an additional 1 second, what would be the actual time that we would plug in? 4. So time is equal to 4. If it's falling for an additional 0.5 seconds, what's the actual time? 3.5, 3.1, and 3.01. So these will give us average velocities as we reduce the amount of time. Again, calculus is about calculating the infinitesimal, okay? So we're looking for, like, say, 0 seconds passing by. Maybe we can get a really good estimation. Now, what I would like to do, because I believe that's a little bit easier, is I'd like to write a slope function. Instead of doing each one of these by hand over and over again, let's write a slope function, okay? So we have P is 344.1, okay? What would Q be? We choose an X value, and in order to get the Y value, what do? You plug it in. And when you plug X into this, you get 4.9. Very good. That's what we have. So let's use this information to write a slope function. M is equal to, what's Y sub 2? (44.1) minus 4.9x squared divided by 3 minus x. Okay, where is this function undefined? At 3. Does that make sense? Because that's the place where we'll be finding the instantaneous velocity at 3. So we will go to our calculators. Let's take out our calculator. Go Gadget Calculator. Got it. And turn our calculator on. We go into y equals, and we type in our function, which was 44.1 minus 4.9 x squared. Tell me if I get this wrong at any time. Divided by, we had 3 minus x, correct? Now, as I look at this piece right here, that's my slope function. So instead of plugging in 4 to 4.9x squared, I can simply use this. I'm going to go to my table. I'll have data from before. I don't want it. Press delete. Can somebody tell me, instead of punching in 4, what might people make a mistake of and do instead? They might punch in 1. Okay, so 4 seconds. 34.3 what? Meters per second. Now what? We do 1.85 meters per second. You have to have the label. If you don't write the label on the AP exam, they take a point off. 3.1. Whoop. 29.89. And 3.01. 29.449. If you were going to try to make a better guesstimation, what could you plug in? Yeah, go ahead and punch in a few of them. So I'm going to go with, it says, find the instantaneous velocity, no time elapsed when t is equal to 3. I'm going to estimate it to be 29.4 meters per second. We see that our values have been kind of converging towards that number. 34 wasn't a great estimation. 31 was better, 29, 29.4, 29.4. And again, what will happen if I plug in exactly 3? Y? It's undefined on the bottom. Okay, and that's that. All right. Any questions on that piece? Pretty good? Okay. All right. Let's flip it over. 1:15, okay? And then when we come back from lunch, we'll do a checkpoint, and you'll be able to work on your assignment. We'll have no problem finishing this, okay? All right, the number of bacteria in a dish is modeled by the given data after T minutes. Ooh, bacteria. Bacteria grows, right? It's kind of disgusting, right? Yeah, like if you open a fridge that has, well, we won't even start. Okay, so after 1 minute, there's 5 bacteria. After 4 minutes, there's 8. After 8, there's 14. After 13, there's 32. And after 20, there's 115. It says find the average rate of growth of bacteria beginning at t equals 1 and lasting 19 minutes. So I want to find average rate. So I need 2 points. Okay? So it begins at time equals 1. So what's my first point? 1, 5. If it lasts 19 minutes, what time am I checking it at? I'm checking it at 20. And how many bacteria are there? 115. Can we now find the slope for the average rate of change? How we do that? Right, so we got 110 over 19, which is, let me do that on your calculator quick. 5.79, we'll call it, bacteria per minute. You go ahead and do 2, 3, and 4 on your own. Okay, there's no slope function for this problem, is there? There's only data. Yet they will ask questions like that on AP exam. You will want a function, but they just give you data, and we can still do that. So what'd you get for 12 for the answer? How about 7? And 3. Okay. You tell me, does that make sense that you have a larger rate of change as you went out to 19? Why? It grows exponentially. We would expect that. And the more bacteria are, there's the more bacteria there are to actually produce, right? Okay. This is continuous growth, right? I mean, it's not like bacteria pauses or anything like that. They're like rabbits. It just grows, right? That's what it happens. So then it says use a graph of the data in order to estimate the instantaneous rate of growth at t equals 8. So this is, you won't like this about calculus, but sometimes there are what we call estimations. Okay, and that's just all there's estimations on the AP exam as well. And so I've just made a graph, and I'm going to do my best to estimate it. Your estimation might be different than mine, but we need to be okay with that. So use a graph of the data in order to estimate the instantaneous rate of growth at time equals 8. We'll make a graph at 1 minute. I have 5 bacteria. So at 1 minute, I have 5. So I have a point way down there, we'll say. And then at 4 minutes, I have 8. So at 4 minutes, I have 8. And then at 8 minutes, I have 14. And then at 13 minutes, I have 32. And then is the last one 20? 20, I have 115, so that's going to go way up here. Okay, and notice what Hannah said. She said that this was exponential growth. And you guys remember that if you take e to the x or 2 to the x, that the graph looks like that, correct? Okay. And sure enough, your anticipation was correct, Hannah. Way to go. Now, what are we trying to estimate? The instantaneous rate at what point? You tell me when I get there. Yeah, right here, right? So we want that slope. What would be a good way to find an approximation of that slope? What 2 points could I use? You could use 8 and 13, couldn't you? Give me another option. You could use 8 and 4. Or you could use, do we have one for 4? I can't read my stuff. Or you could use 4 and 8, or 4 and, yeah, doesn't it look like the slope from 4 to 13 is about the same as that? I would say you have 3 reasonable options here. 4 to 8, 8 to 13, or 4 to 13. It's up to you. I'm going to use 4 to 13. So that means, how many bacteria do I have at time 13? 32. At time 13, I have 32. How many bacteria do I have at time 4? 8. That's my choice. I think that green secant line has a slope that's about the same as the red one. So that's what I'm going to choose to use. When I do that, I get 24 divided by 9, which is, let's see, 2 2/3, so 2.67 bacteria per minute. And that's my estimation, and I'm sticking to it. Question? Yes. Well, I estimated the slope of the red line by finding another segment that was similar to that slope. So some people suggested that we use this one right here. Other people suggested that we use this one right here. I used the green one. You could choose any of those. If you would have chosen from 13 to 20, I would have said bad choice. I would not give you the points. Yeah, I think 1 to 4 isn't the best choice. You know, something around 8. Yep. Okay, checkpoint when we get back in assignment. You have the rest of the time to work. Yes. Okay, so we just did a checkpoint. Those who are watching, no big deal. You don't have to do it. The assignment is going to be 2.1, page 70, and do numbers 5 through 8. Okay, we just did a checkpoint, so there you're good to go. Have a great weekend. We'll see you on Monday.